So this is what we understood about the function from a plane to a plane. Now the challenging question is to understand the functions from 3 space to 3 space. And physics interpretation of such a function could be the vector field in 3 space, when each point in 3 space gains a vector, a velocity vector, and then, of course, the similar type of simple functions, linear functions, should be considered first, and a linear function would be represented by a matrix which is going to be 3 by 3. And the question would be, is it true that any linear flow of media in 3 space can be decomposed into the sum of 3 relatively simple flows like gas and liquid and solid? And then if yes, then how to describe those matrices? What kind of matrices identify the gas behavior, liquid behavior, and solid behavior? And well, just a curious question would be to see the number of parameters needed to describe each of these behaviors. For example, for the gas behavior here, we understood that it depends on one parameter only, on this rate of expansion. And algebraically, it's just a coefficient with the identity matrix. So it is one parameter family. The circulation is completely described by one coefficient with that matrix, but liquid behavior is described by 2 coefficients. L1, the coefficient with that matrix, plus L2 times 0, 1, 1, 0. So, in some sense, the gas and solid types are one-dimensional and liquid type is two-dimensional, so that the sum of all these dimensions makes the dimension of all the matrices, dimension 4, dimension of all those 2 by 2 matrices. Now in 3 by 3 case we have 9, the dimension of the space of all matrices. So if we are to observe the decomposition in 3 types of behaviors, then we should expect the sum of those dimensions, the sum of corresponding dimensions, to be 9. And then the question would be, well, how many dimensions, how many parameters are there in the gas, liquid, or solid types? Now, actually, once you understand that, there is no difficulty extending all that to functions from 4-dimensional space to 4-dimensional space. And actually even further, functions from n-dimensional Euclidean space to n-dimensional Euclidean space. And these kind of functions can be interpreted as vector fields in the corresponding space when each point gains a velocity vector assigned. Now the question is, yes, of course we can go into those higher dimensions, carrying out all the algebra using this formalism of matrices. Now, what is the point? I mean, why would anybody want to understand the flow of gas or liquid or solid in 4-dimensional space? In 3-dimensional space, yes. We live in 3-dimensional space, we want to understand it. But in 4-dimensional space, in 5-dimensional space, well, there is a big question. Why? Why would we want to study all that?